So if Q's out here on the end, what's the piece on the end? Control. It's not on the inside, so it's not horizontal. Everyone agree? It's something to do with the vertical movement or vertical changing of the graph, because it's on the outside. Bryce?
Take the vertical translation up and down.
It's a vertical translation up Q units. Vertical is what it is. Whatever you see from a vertical perspective, you just do it. The inside, the horizontal work is always opposite. Behaves in a funny manner. Okay? If Q is less than 0, what's happened to the graph? Moving it down. Okay? If H is greater than 0, what do you get? It's right. So this is where this is the reason why things behave in an opposite manner. This is kind of your stock equation, and then the stock equation changes in response to what H is specifically. Okay, so if H is positive, H is the horizontal translation by definition. If it's positive, it's moving right, but it appears in the equation that it's negative because that's just what the equation is. Okay, so H is greater than 0, the function is translated to the right. H specifically, but you're going to see negative, we're going to see x minus positive H. You see that? Is that clear enough or no? Okay, and if H is less than 0, you're going to see this. It's going to move left because H is less than 0. But the equation, or what you're going to see in the function notation, is going to be opposite of what you see because it's going to appear like x minus negative H. The two negatives make a plus sign. It appears it's moving to the right, but the actual horizontal translation is left. It's negative. So in theory, like, the horizontal translations are what they are, but they appear in the function notation to be opposite. Okay, this is kind of the reasoning behind why we're seeing it to be opposite. Okay, it's totally because of what that is, the actual x minus h piece. Okay, so let's describe, if we go down, describe the transformations that have occurred to this graph. F of x, we took, I don't care what the function is, it could be the root x, it could be x squared, it could be the rational function, whatever it is. What happened to it in A? What is that? You're comparing to this, right? Do you see an H? You see any number on the inside of the brackets? So what is that? Identify the variable, like the component of the function notation, Bryce.
The vertical translation.
That's Q, right?
Yeah.
This is Q.
Yeah, well, that's only one.
It's on the outside, yeah, right? So we're moving down. We're taking the original graph and we're vertically translating it down 3 units. It's not on the inside of the brackets. It's not horizontal. It's Q. Okay, so we're vertically translating. Okay, what's where now? What's happening in B? Again, I don't care what the function is. It doesn't actually have to be a function. It could just be a relation, a bunch of points. You take all those points on like a scatter plot of like 6 points and do what to all the points? Doesn't matter what it is. That's why we like this, right? Doesn't matter what the function is if it's just an assortment of points on a grid. f of x is something. What is it telling you to do to the something? We're horizontally translating to the left 5. Everyone agree? Whatever it is, it's all moving to the left 5, right? Okay, and this one's got both in it. That's H. This is H and Q. Okay, so today's lesson has dealt with 4 transformations. Tomorrow we'll do the other 2, and then we're done. 6 total. Okay, and then it becomes a recognition game of what's what, right? And when to do what. Okay, so today we've looked at the reflections, vertical and horizontal, okay, as well as horizontal and vertical translations. Tomorrow, we will look at vertical stretches and compressions, as well as the new one being horizontal stretches and compressions. You have not done those yet. Okay, so this is horizontally translated. There's both of them are here. How much? And where? RJ?
2 to the right.
Yeah, 2, good. 2 units right. And we're vertically translated. Four units up. Okay. Is everyone okay? So let's go down. Okay, here's your function. What function is that? Of the 5, it's the hook. It's 3 points. Dylan answered that question yesterday. It's good. He knows the hook function. Down pat, 3 points. One of them is at the origin, so really 2 points. 0, 0, 1, 1, 4, 2. Pot those points. Do what it tells you to do. No different than the quadratic stuff from last year, right? So we're going to plot the original, the hook, right? And then we're going to transform that graph based on what it's telling me to do. State the transformations first, though. Let's do that. We're going to, there's 2 of them, H and Q. What's it telling us to do? Gabe? Yeah, so we're going to horizontally translate. Uh, 4 units left. And then we're going to vertically translate. Uh, 2 units down. Okay. So if you really think about it, like it's the exact same work we've done before, just a different looking graph. And then we're gonna tack on this idea of the domain range that we've done. Okay? Because the domain range really, like, the more you do this, the domain range really gives you a really good idea as to what that graph looks like, or at least where it exists. Okay, and where it does not exist. Okay, so do what it says. We're gonna horizontally translate 4 units left, down 2. So we're gonna get something that looks like this. 4 left, down 2. All points. 4 left, down 2. Oops. Oops. Okay, the domain range. This is maybe one of the ones that are a little bit more interesting from a domain range perspective because they're different. Like the original domain range is much different than the transformed domain range. Okay. So for the domain, what are we seeing? This is not spaced very well. Any restrictions on X?
Yeah.
Okay, where?
X is the real numbers such that X is equal to or more than -4.
Perfectly. And what about the range? Right, for anybody that's like, oh, what's going on here? It definitely does not go anywhere back here. That's the domain, right? So it's all values of X that are to the positive side, not the positive side, the right side of that X equals -4 line. And all the range values are above what? They definitely take on all the values of Y under the condition that Y is greater than or equal to -2.